According to National Electrical Code Section 210.8A3, ground fault circuit interrupter, often abbreviated as GFCI, protection is required for receptacle outlets installed outdoors. This requirement applies universally to all outdoor receptacles, irrespective of the height of the building on which they are installed. The rationale behind mandating GFCI protection for outdoor receptacles stems from the critical need to safeguard individuals from the hazards of electrical shock. The risk of electrical shock in outdoor environments remains constant, irrespective of the building's height. A ground fault circuit interrupter is a safety device designed to quickly interrupt an electrical circuit to prevent serious injury from electrical shock. It works by monitoring the amount of current flowing from hot to neutral. If there is any imbalance, meaning some current is leaking to ground, the GFCI trips the circuit. This leakage often happens when electricity flows through a person, providing a path to ground. The speed at which a GFCI trips is crucial. It is designed to trip quickly enough to prevent electrocution. The tripping time is typically around 20 to 30 milliseconds. This rapid response is vital in minimizing the duration of electrical shock, thereby significantly reducing the risk of serious injury or death. GFCIs are commonly found in areas where electrical outlets are near water, such as bathrooms, kitchens, and outdoor locations. The NEC mandates their use in these areas to enhance electrical safety. In addition to receptacle outlets, GFCIs are also used to protect entire circuits or specific appliances. There are two main types of GFCIs: receptacle type and circuit breaker type. Receptacle type GFCIs are installed in place of standard outlets. They provide protection only at that specific location. They typically have test and reset buttons on the face of the receptacle. Circuit breaker type GFCIs are installed in the electrical panel and provide protection for the entire circuit. They also have a test button for periodic testing. Regular testing of GFCIs is recommended to ensure they are functioning correctly. The test button simulates a ground fault, causing the GFCI to trip. If the GFCI does not trip when the test button is pressed, it should be replaced. Several factors contribute to the need for GFCI protection in outdoor environments. Firstly, the presence of moisture increases the risk of electrical shock. Rain, humidity, and standing water can all create conductive paths, making it easier for electricity to flow through a person. Secondly, outdoor environments often involve direct contact with the ground. This provides an easy path for electricity to flow from an electrical source through a person to the ground, completing the circuit. Thirdly, outdoor electrical equipment, such as power tools and lighting fixtures, are often exposed to the elements, which can damage their insulation and increase the risk of electrical leakage. GFCI protection is particularly important for outdoor receptacles used to power portable electrical equipment. This equipment, such as lawnmowers, power washers, and electric drills, can be used in wet conditions or near water sources, increasing the risk of electrical shock. GFCI protection is also essential for outdoor lighting fixtures. These fixtures are often exposed to rain and other elements, which can damage their insulation and increase the risk of electrical leakage. In addition to NEC Section 210.8A3, other sections of the NEC provide further guidance on the installation and use of GFCIs. For example, NEC Section 210.8A4 requires GFCI protection for receptacles installed in bathrooms. NEC Section 210.86 requires GFCI protection for receptacles installed in kitchens. NEC Section 210.8D requires GFCI protection for equipment installed outdoors. When installing GFCI protection, it is important to follow the manufacturer's instructions and all applicable electrical codes. Improper installation can reduce the effectiveness of the GFCI and increase the risk of electrical shock. It is also important to periodically test GFCIs to ensure they are functioning correctly. The test button on the GFCI should be pressed monthly to simulate a ground fault. If the GFCI does not trip when the test button is pressed, it should be replaced. Ground fault circuit interrupters are an essential safety device that helps to protect people from electrical shock. By quickly interrupting an electrical circuit when a ground fault is detected, GFCIs can prevent serious injury or death. In conclusion, the requirement for GFCI protection of outdoor receptacles, as mandated by NEC Section 210.8A3, is a critical safety measure that applies universally to all outdoor receptacles, irrespective of the building's height. This requirement is based on the fundamental need to protect individuals from the hazards of electrical shock, which are amplified in outdoor environments due to factors such as moisture, ground contact, and exposure to the elements. GFCI protection is particularly important for outdoor receptacles used to power portable electrical equipment and outdoor lighting fixtures. Proper installation and regular testing of GFCIs are essential to ensure their effectiveness in preventing electrical shock. By adhering to the NEC guidelines and taking the necessary precautions, we can create safer electrical environments for everyone. The NEC is a comprehensive set of standards that outlines the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest technological advancements and safety practices. The NEC is not law, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Adherence to the NEC is essential for ensuring the safety of electrical installations. In addition to GFCI protection, the NEC also covers other important safety topics such as grounding, overcurrent protection, and wiring methods. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow. This helps to prevent electrical shock and equipment damage. Overcurrent protection is the use of fuses and circuit breakers to protect electrical circuits from excessive current. This can prevent fires and equipment damage. Wiring methods are the techniques and materials used to install electrical wiring. The NEC specifies the acceptable wiring methods for different types of installations. Electrical safety is a shared responsibility. Electricians, contractors, and homeowners all have a role to play in ensuring that electrical installations are safe. By following the NEC guidelines and taking the necessary precautions, we can create safer electrical environments for ourselves and others. The NEC is a valuable resource for anyone involved in electrical work. It provides clear and concise guidance on how to install electrical wiring and equipment safely. The NEC is available for purchase from the National Fire Protection Association (NFPA). The NFPA also offers training and certification programs for electricians and other electrical professionals. Continuous learning and professional development are essential for staying up to date on the latest electrical safety practices. Electricians and other electrical professionals should regularly attend training courses and read industry publications to enhance their knowledge and skills. By investing in education and training, we can improve the safety of electrical installations and prevent electrical accidents. Electrical safety is a critical aspect of building safety. Safe electrical installations are essential for protecting people and property from electrical hazards. By adhering to the NEC guidelines and taking the necessary precautions, we can create safer buildings for everyone. The electrical inspections are an important part of the building safety process. Electrical inspectors review electrical installations to ensure they comply with the NEC and other applicable codes. Electrical inspections help to identify and correct potential electrical hazards before they can cause harm. Homeowners should have their electrical systems inspected periodically by a qualified electrical inspector. This can help to identify and correct potential electrical problems before they become serious. Electrical maintenance is also important for ensuring the safety of electrical systems. Electrical equipment should be regularly inspected and maintained to prevent failures and hazards. Homeowners should perform basic electrical maintenance tasks such as replacing light bulbs and checking for damaged wiring. More complex electrical maintenance tasks should be performed by a qualified electrician. Electrical emergencies can happen at any time. It is important to know what to do in an electrical emergency. If you suspect an electrical fire, evacuate the building immediately and call 911. If someone is in contact with electricity, do not touch them. Turn off the power at the breaker box and then call 911. Electrical safety is a serious matter. By taking the necessary precautions and following the NEC guidelines, we can protect ourselves and others from electrical hazards. Remember to always use caution when working with electricity. If you are not comfortable performing an electrical task, hire a qualified electrician. Your safety is worth it. Consider some advanced topics within the domain of GFCI protection. Firstly, there's the concept of ground fault protection of equipment, often abbreviated as GFP. While GFCIs are designed to protect people from electrical shock, GFP is designed to protect equipment from damage due to ground faults. GFP devices typically trip at a higher current level than GFCIs, allowing for normal equipment operation while still providing protection against ground faults that could cause equipment damage. Secondly, there are different classes of GFCIs, each designed for specific applications. For example, Class A GFCIs trip at 5 mA, which is the level required for personnel protection. Class B GFCIs trip at 20 mA, which is often used for equipment protection. Thirdly, there are advanced GFCI technologies that offer enhanced features, such as self-testing and ground fault indication. Self-testing GFCIs automatically test their functionality on a regular basis and provide an indication if a problem is detected. Ground fault indication GFCIs provide a visual indication when a ground fault has occurred, making it easier to troubleshoot electrical problems. Fourthly, there are specific requirements for GFCI protection in different types of occupancies. For example, the NEC has specific requirements for GFCI protection in healthcare facilities, industrial facilities, and agricultural facilities. These requirements are tailored to the specific hazards present in each type of occupancy. Fifthly, there is the topic of coordination between GFCIs and other protective devices. It is important to ensure that GFCIs are coordinated with other protective devices such as circuit breakers and fuses to prevent nuisance tripping and ensure that the proper level of protection is provided. Coordination studies are often performed to determine the optimal settings for protective devices in an electrical system. Sixthly, there is the issue of GFCI protection for existing installations. The NEC allows for some exceptions to the GFCI requirements for existing installations, but it is generally recommended to upgrade existing installations to meet the current GFCI requirements whenever possible. Upgrading to GFCI protection can significantly improve the safety of existing electrical systems. Seventhly, there is the topic of GFCI protection for temporary wiring. Temporary wiring is often used at construction sites and other temporary locations. The NEC has specific requirements for GFCI protection of temporary wiring to ensure the safety of workers and the public. Eighthly, there is the issue of GFCI protection for underwater lighting. Underwater lighting is used in swimming pools, fountains, and other water features. The NEC has specific requirements for GFCI protection of underwater lighting to prevent electrical shock hazards. Ninthly, there is the topic of GFCI protection for electric vehicle charging equipment. Electric vehicle charging equipment is becoming increasingly common, and the NEC has specific requirements for GFCI protection of electric vehicle charging circuits. Tenthly, there is the issue of GFCI protection for solar photovoltaic systems. Solar photovoltaic systems generate electricity from sunlight. The NEC has specific requirements for GFCI protection of solar photovoltaic systems to prevent electrical shock hazards. GFCI protection is an essential safety feature for electrical systems. By understanding the different types of GFCIs, the requirements for GFCI protection in different applications, and the advanced technologies available, we can ensure that electrical systems are properly protected and that people are safe from electrical shock hazards. Understanding and applying these advanced concepts requires a thorough knowledge of the National Electrical Code and a commitment to electrical safety.